Coming up on Garden Talk.
You put so many materials, so many ions in the root zone that it creates a high pressure gradient outside the roots, which forces it into the plant. Anything that you're adding microbially is going to create in its own environment, and it's going to create some slimes and films, and you're not going to know what's going on. So it's kind of bro science just to be like, oh, all microbes die whenever you put synthetic fertilizers on there. That's not true. It's very much of a gray area where, yes, some are super sensitive, but some are actually really resistant to these chemicals we're putting down and actually can help synthetic systems. If you brew a compost tea, do not adjust the pH. Whatever it is, put it inside your medium, and the buffering index inside your soil will figure out where it wants the proper pH to be. Grow more plant matter. Carbon-based systems are going to grow more cannabinoids, more alkaloids within the plant.
What's up, everybody? If you that don't know me, my name is Chris, aka Mr. Grow It, and you're tuned into the Garden Talk podcast. This is episode number 41. In this episode, I interview Tim McCormick. He is the owner of Cultured Biologix, which is a company that formulates and manufactures an organic product line. Tim has an extensive background in horticulture, everything from chemistry, microbiology, soil science, plant physiology, entomology, and plant pathology. In this episode, he breaks down bro science versus grow science. We go over a ton of different gardening processes that many deem as bro science. Tim reveals the actual science that exists for them, if any. Thanks to all of you who support this podcast through Patreon. If you'd like to support, you can do so by going to patreon.com/MrGrowIt. Before we get into it, I want to acknowledge that one of my goals for this podcast is to bring zero cost for information about gardening, all plants, to the general public. That being said, I'd like to thank the sponsors of this podcast who help make that goal possible. Big shout out to AC Infinity for sponsoring this podcast. AC Infinity is well known to produce high quality products and provide excellent customer service. They have the thickest grow tent on the market today, inline fans with a controller that can automatically turn on and off according to specific set points. They have seedling mats, trimmers, drying racks, and several other products that you can use in your garden. I will leave a link to AC Infinity down in the description section below, and you can use discount code MrGrowIt during checkout for a discount on their products. A big supporter of this podcast is Dutch Pro. They sponsor this podcast, and I use their nutrients. I have been using their base nutrients formulated specifically for RO and soft water. I also have been using some of their additives like CalMag, Silica, and their root stimulator called Take Root. They have a few other additives on top of those, and pH regulators. Coupon code MrGrowIt10DP will get you a discount on their products, and I'll leave a link to their Amazon store down in the description section below. Thanks to Spider Farmer for sponsoring this podcast. They have board-style LED grow lights, bar-style LED grow lights, grow tents, inline fans, and carbon filters. They also have complete grow tent kits, which include lighting, a ventilation system, grow pots, a trellis net, a timer, and a monitor for both temperature and humidity. Coupon code MrGrowIt5 will get you a discount on their products, and I'll leave a link to their Amazon store down in the description section below. And we are back. Welcome to the Garden Talk podcast. Today I am joined with Tim McCormick from Cultured Biologix. How you doing today?
Good. How you doing, Chris?
I'm doing great. Excited for this episode today. We're going to be talking about bro science versus grow science. So basically I have a whole bunch of highly debated topics that many people swear work, while others claim that it's just bro science, man. So Tim and I met at MJ BizCon, and I thought Tim would be the perfect person to have on this since he has such deep knowledge in several different areas of horticulture. You've actually developed your own organic fertilizer as well. It's 100% water soluble. Yep. We'll get into that in more detail later on. But yeah, this is going to be a great episode. First, can you give the listeners an introduction? Maybe tell us a little bit about yourself and kind of how you got into gardening?
Oh, yeah, absolutely. So my experience with gardening goes back to my childhood pretty much. My mother is has been a horticulturalist for like 35 years. So take your kid to work day was take Tim to the greenhouse, make him water, make him pick off leaves, make him go move pallets and the boxes of plants and stuff like that. So I've been gardening since I was a little kid, but my real career experience got started when I got out of college. Didn't really know what I wanted to do. Got a degree in chemistry, emphasis on like compound pharmacy. So it was, how to make medicine for people. And I didn't really like how the pharmaceutical industry was kind of how it's kind of geared to making pills for pills for pills, and it's not really where I wanted to come from. Really wanted to make natural medicine for people. So kind of got out, didn't really know what I want, and then by happenstance got to meet a business owner trying to start up a fertilizer company out of Fort Collins. Asked me and my best friend Greg if we wanted to move. He's a marketer. Wanted to move to Colorado to start a career in the fertilizer industry. And being a compound chemist, I was like, absolutely, like let's do it. I have experience with growing. So at the time, I was growing my own medicinal plants inside my closet. You know, just trying to go to school for chemistry, kind of growing plants hydroponically at the same time. Then kind of got thrown into this mix of the fertilizer company, and from there I got to travel the world, working with agrochemicals in Latin America, domestic agriculture. So my career background is in commercial agriculture. So I come from, instead of the hydroponic industry being where I started with commercial agriculture, and got to do some really cool stuff with the CATIA. It's a Latin American university that does cacao genetics. They do bananas, pineapples, so a lot of tropical fruits. Then I came over to working with the University of Florida Extension Program. Really got into how to use these, organic chemicals on our fertigation systems, our irrigation technologies. So really, my background really stems from me trying to take these organic materials that we were making with our fertilizer company and applying them to our industrialized technology and trying to find a hybrid. About 4 years ago, my best friends and I decided to break off and start Cultured Biologix, formulating our own organic fertilizers, microbial inoculants, biopesticides. And so we've been doing this for about 4 years now, pretty steadily. So I'm just in the process of now releasing all my formulations.
That's awesome. Yeah, I mean, you mentioned through DMs, chemistry, microbiology, plant physiology, soil sciences, plant pathology, so a whole bunch of different areas what you have knowledge in, which is awesome. That's really cool.
Yeah, it was actually really cool. I didn't, a lot of people go get their bachelor's and master's and PhDs and postdoc and whatnot. I kind of got, I quote, a pseudo master's working with the University of Florida Extension Program, because I got to work with plant pathology professors, entomology professors, soil scientists. At some point when I was working down in Latin America, worked with the United Nations Food and Agriculture Organization, and they kind of taught me regenerative agriculture and what we need to do to kind of repair the land throughout the world. And even it kind of merged into my own degree with pharmaceuticals, where the European Commission, we were working with the European Commission on trying to figure out how to reduce healthcare costs. And after all the scientists and hundreds of people at symposiums trying to figure out how do we reduce healthcare, the number one thing it came back to is growing nutritious food. So it's really cool. Like, it was a real full circle experience for me. Trying to figure out how to grow food better and how to make people healthier.
That's awesome. That's really cool. All right, first thing, let's dive into powdered nutrients versus liquid fertilizer, right? So many people claim that 99% of the liquid in liquid fertilizer is water. So you're mostly paying for water. My question is, how much liquid fertilizer bottle is water? And is all of that actually required, right? Like, I know water needs to be in there so, chemicals don't bind together,
right,
unexpectedly and so forth. But is it true that 99% is water? Are companies ripping off consumers by giving excess water in their fertilizer?
That's hard. There's not exactly a clear-cut answer to that. So water suspends, right? Water is a solvent. There's only a certain amount of salt you can put into water till it starts falling out. I mean, imagine you putting in sugar into a glass of water. It's going to dissolve, it's going to dissolve, it's going to dissolve till you put too much in there, and then it's going to start falling out and it won't go into it. So from a chemical point of view, you do need water, you do need other dissolution agents like weak acids and things like that to kind of keep all the salts broken down, to keep everything from binding together, like you said. But commonly it's like 50 to 80% water usually. I try to keep that on the low end for when I make my liquid formulations. But there's a lot of, the hydroponic industry is taking all these concentrated salts and putting them in the liquid form and diluting them essentially. Powdered salts being as the most concentrated, we do have a smaller amount of salts going into the hydroponics. So most of the time it is watered down salts. And everybody sells the same general formulations with the same amount of water in it, and it's pretty wasteful, especially when you get to like the shipping end of things. So quick answer, 50 to 80%. Long answer doesn't always apply to that.
Gotcha. Okay. Now let's talk about organic versus synthetic. So,
Sure.
When talking about synthetic nutrients, they're already in a form that is available for the plant to uptake. They're in an ionized form, right?
Right.
With organic, a lot of these amendments, they need to be broken down by microbes first, and then put into a form that the plant can uptake. You can easily overfeed using synthetic nutrients because the plant is just going to continue to uptake. A lot of people call this force feeding. That's what they refer to it as. When it comes to organic, many people say you can't over-fertilize when growing organic because the plant is only going to uptake what it needs when it needs it via the exudates it releases for the beneficial bacteria that's in the rhizosphere, and that exchange is happening between the exudates being released, being exchanged for the potential nutrients. So my question is, can you over-fertilize when growing organic?
Yes, you can. You can overdo the kelps, you can overdo the alfalfas, you can definitely overdo the guanos. You just understand these materials still have nitrates and phosphates in them. Blood meal has lots of nitrates. Guano has lots of phosphates and nitrates usually. So if you put too much down, and I've done this before on my outdoor properties, you can nuke a crop real easy. So some of it takes time to break down. Some of it's pretty available immediately. The biggest difference between the synthetic is you create osmotic pressure at the root zone. So you put so many materials, so many ions in the root zone that it creates a high pressure gradient outside the roots, which forces it into the plant. And you can kind of train a plant. This is why you see people like with Athena and Front Row, and they can get up to like 5 EC in peak flower because they've been training their plant to take that osmotic pressure, and they work the plant up to it. Whereas like the organics, like we just said, the exudates, the mycorrhizae, the beneficial bacteria, the network will slowly break down and make compounds in a form that the plant can just take up passively. So it's really hard to overdo or overfeeding organics, but you can't do it. So it's like I said, in organics about finding an equalization and harmonization between the life in the soil and the materials that are required to be broken down for plant nutrition.
Okay. And then diving deep into the microbes side of things, when using synthetic nutrients, like we mentioned before, they're in ionized form, already available for plant uptake. Are microbes useful when using synthetic nutrients? Some people say it is. Some people say that microbes are going to be able to survive in a high salinity environment, and it's going to be useful when using synthetic nutrients. Other people say that microbes are completely pointless. You should not be inoculating your medium when using synthetic nutrients. What's the real deal with that?
So it's funny you ask that, because I just had this conversation with Colin from Crop King the other day. Awesome consultant, awesome dude for all things plant related. But he had the conversation of he doesn't believe microbes are needed in a hydroponic medium. And so my answer is kind of twofold. First, you have to break down hydroponics and like synthetic fertilizers. Like, are you using just water culture? Are you using any substrates? Because cocoa and peat are still inert, rock wool is still inert, and they're still hydroponics, right? So when I go to water culture, I like to keep everything as sterile as possible. Anything that you're adding microbially is going to create in its own environment, and it's going to create some slimes and films, and you're not going to know what's going on. The only time I will say microbes are effective in the water culture specifically, so like your deep water culture, your aeroponics, your sprinkler irrigation, all that fun stuff. The only time that you really are, I feel microorganisms are effective is using them as biopesticides. Trichoderma, certain strains of bacillus produce antifungal, antibacterial compounds that you can, like Root Shield or Bavaria brassiana with Botanicare, or Botanigard, sorry. All of those are really good for protecting the root system, killing any type of pest that might be in the root system, but I wouldn't be using any type of nutrient cycling bacteria or any type of mycorrhizae in a water culture synthetic system. My second part of this is like if you use a substrate medium like cocoa, rock wool, peat, and it's all inert, still hydroponics, but you have a substrate for the organisms to live within. And here is where you find the usefulness of microorganisms, I feel. Mycorrhizae, it can be helpful, it can be handy. With mycorrhizae, it requires an insoluble phosphorus source. And then the mycorrhizae takes that insoluble, like rock phosphate. It takes that insoluble rock phosphate and it digests it and breaks it down, and then it's connected intravenously within the plant. So then it just injects the phosphorus in there. When you're using synthetic phosphates, you're not giving the mycorrhizae any food. You're not giving it any of its natural function to actually survive inside the media. And so I don't really think mycorrhizae is a good choice when you're using synthetic hydroponics. And then when you have the nutrient cycling bacteria, plant growth promoting rhizobacteria, they release natural hormones around the root systems to increase root production. They can help stabilize the pH so you don't get pH fluctuations throughout your synthetic crop cycle. You it can also help break down if salts do end up binding together and locking you out, or coming together and creating some precipitant molecules in there. You start to see the white crust on the top of your substrate. The nutrient cycling bacteria like the bacilluses can help break that down and alleviate lockout and just keep ppm steady. So it really depends on what you're trying to do. It's very much of a dynamic answer, I guess. But I mean, using SLF 100 enzymes, always good. It just keeps everything clean. It keeps everything broken down. We have a product called Flush. It's weak organic acid. Use those to keep everything broken down. I don't really suggest going really hardcore with the microorganisms inside a synthetic system.
Okay, so you mentioned hydroponic system, inert mediums. You wouldn't necessarily go towards using microbes. But how about soil? You did mention some benefits that really microbes can be useful in soil when using synthetic nutrients. Is that right?
Yeah, I mean, I try to steer away from using synthetics in any type of soil, just because you have a rhizosphere, an environment in the root zone where you need to take care of certain microorganisms, and sometimes they can be really sensitive to the synthetic fertilizers. Most of the time, nutrient cycling bacteria are okay with it. Sometimes you can really impact a mycorrhizal network by using high phosphates. But if it comes to water culture, I stay away from everything microorganism related outside of biopesticides. Your trichodermas, your bacillus, your antifungal, antibacterials. If you're in an inert medium like cocoa, like peat, rock wool, I like to throw in nutrient cycling bacteria for their ability to create hormones around the root zone, cycle nutrients, stabilize the pH. If I'm in soil, I go very, very heavy with microorganisms and try to stay away from salts as much as I can. Salts can tank out the microbial sphere that you've created. So keep it organic. Soil is supposed to be a slower uptake anyways, and that's why you rely on the microorganisms to kind of be the fuel in the car, the gas pedal. The more microbes you usually put into an environment, within good means, the better off your soils do, because they can break down all the amendments that are unavailable to the plant.
That actually goes right into my next question, which is, in a lot of organic growing books and you hear documentaries and stuff, synthetic nutrients killing off microbes. And then you got people on the opposing side of things that say, no, synthetic nutrients, microbes actually consume those. So do synthetic nutrients really kill microbes, or is that bro science?
That's bro science.
Really?
Listen, these microbes, you can put a microbial spore on, like a bacterial spore, a fungal spore, on a meteorite, shoot that meteorite to Pluto, and as long as Pluto has an environment that is conducive to microorganisms being alive, the proper oxygen, the proper CO2, all the food sources and things like that, it'll come alive. I mean, we use spore-forming bacteria all the time, with our teas, and they can resist. These spores themselves can resist 2,000 ppm of synthetic fertilizer. They can withstand a pH swing of 4.0 to 9.0. They can, as long as they have a conducive environment to germinate, these microbes will come alive. And actually, some of these nutrient cycling strains and subspecies of bacteria we're finding actually solubilize some of these salts. A lot of soil remediations that I've been doing throughout my decade of experience in agriculture, we use microorganisms to remediate high salinity soils. So it's kind of bro science just to be like, oh, all microbes die whenever you put synthetic fertilizers on there. That's not true. It's very much of a gray area where, yes, some are super sensitive, but some are actually really resilient to these chemicals we're putting down and actually can help synthetic systems.
Got it. Okay. Another thing that people get caught up on is pH adjusters, like using pH up and pH down. Just for the audience, I've asked these questions to other people as well on the podcast. I like to ask multiple people this questions, you know what I mean, see if the answers vary a little bit. So far, they've been about the same. But pH adjusters, so people commonly use for pH down phosphoric acid. pH up, people commonly use, it's usually a potassium hydroxide or a potassium carbonate. People swear that if you're using those to adjust your water or nutrient solution, once you pour that into medium, you're killing off microbes. What are your thoughts on that?
No. Really, it comes down to, it's so funny how some of these isms, as I call it, get kind of spun up a couple different ways as the years go on. But so adjusting your pH up and down with phosphoric acid, strong bases, isn't going to tank out your soil. The thing about soil is that you have what we call a buffering index. And this buffering index is what counteracts the acidity or the alkalinity inside your soil. The organic matter inside your soil, the compost, the worm castings, all of those are buffering agents that are going to help protect the living organisms inside the soil. Now, what I will say with that, when you're making compost teas, like brewed compost teas, like you put your worm castings, you put your compost with your molasses in your water and you aerate it for 24 hours, you just create a living network of I call it a biofilm. It's a long network of bacteria layered on top of each other that creates these long strands of filaments. When you start, because it's already took 24 hours to condition itself, it's at its optimal pH. It's consuming the carbohydrates at an optimal level. When you take that and then you start pH upping and pH downing the colony, the living colony of brewed bacteria and fungi that you just created, yes, you will impact it. If you just general stance, if you brew a compost tea, do not adjust the pH. I don't care if it's 5.5. I don't care if it's 6.0. I don't care if it's 7. Whatever it is, put it inside your medium, and the buffering index inside your soil will figure out where it wants the proper pH to be. So if you're using a brewed compost tea, yes, it will harm, phosphoric acid will harm the bacterial network. If you're using an instant tea, like all these instant microbials, like our Easy Tea, we use bacterial spores. It's like I just went over, like those can withstand high pH swings. So if you need a pH in instant microbial mix, you'll be fine. If you use a liquid inoculant like a Microbe Life, I would treat it like like you just brewed a tea, because they are living organisms. And the other thing is I guess the latter part of this conversation is, it's really, 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 really hard to kill microorganisms with pH swings. They don't really die; they go dormant. And I feel like it's a lot of things in our industry is overly oversimplified, and as we do these podcasts and as we watch YouTube videos, people doing different gardening segments, the telephone game can kind of happen. So just I guess just a side note, bacterial won't die because you put it in an improper pH. It's going to go dormant, and it's going to wait till the pH range gets in a proper range that the bacteria can come back alive, and then it'll regain function.
Okay, that makes sense. A lot of good information there. One more follow-up on that. So the people that swear that you should be using an organic method for pH up or pH down, like for example, pH down, they swear you should use lemon juice or vinegar instead of phosphoric acid, or they swear that you should be using baking soda for pH up instead of the potassium hydroxide or potassium carbonate. Would you agree with that? Disagree with that?
It really depends on your medium. If you're in a very sterile hydroponic medium. Those strong acids, the strong bases, the hydroxides, the phosphoric acids, those are fine. They will work just fine. If you're in a soil, I do recommend, and you have if you have a living microorganism environment to be concerned about, you go with the weak acids, the weak bases. So it's like citric acid, like your lemon juice, your acetic acid, your vinegars. Those are all weak acids that won't harm your skin. Our flush is actually a weak organic acid, and you can put on your skin. It's actually a great skin cleaner. But it's so gentle that it won't harm your skin. It won't harm any type of the organisms. If you're using any type of pH up, like I said, hydroxides work in a sterile environment. I don't like introducing hydroxides into my organic systems. That also goes with kelp extracts, the 1,0,18 kelp extracts. Kelp is organic. Kelp can be used in organic systems, but that 18% potassium is strictly from potassium hydroxide. I wouldn't recommend putting that inside of a organic system because of hydroxides. If you're going to do it, use carbonates, calcium carbonate, potassium carbonate. If you're trying to pH up, limestone is liquid, like calcium carbonate, potassium carbonate. Those are all good alternatives to those really heavy chemicals that you can use in like synthetic hydroponic systems.
Okay, gotcha. I think that's a pretty good transition into your product lines. So if we're going to talk about some of the bro science versus grow science to start, then we'll get into your product lines, so some people aren't like, oh, this is just an hour-long infomercial for his product line. But it really intrigues me. You've developed an organic fertilizer that's 100% water soluble.
Yes.
So you have a Grow 360, a Bloom 360. You also have the PK Blossom, the Calcium, and the Flush.
Yes.
You want to talk to us about what's in the Grow 360 and Bloom 360, how those work?
Sure. It's a true one-part fertilizing system. It's a one-part vegetative base. It's a one-part bloom base. First and foremost, what I want to do is get away from the 6 to 20 bottles people have to constantly mix and be a cocktail mad chemist, So I want to keep it as simple as possible. So if you just need to just grow your plants as simple as possible, you can just take these two products and it has all your macros, all your secondaries, all your trace elements. One's just arranged for the vegetative stage, and the other is for the blooming and fruiting stage. With that, we use zero nitrates. We only use protein nitrogen. We don't use any lab-made phosphates. It's all rock phosphate. So we talked about earlier about mycorrhizae needing food source. Well, rock phosphate is the food source for mycorrhizae. Rock phosphate's in all of our indigenous soils on our earth. Then on top of that, we use calcium carbonate and magnesium sulfate. Both of those have been attached to amino acids, so they're amino-based. And then our trace elements, I don't use any EDTA chelated anything. And that's where we talk about plants being force-fed. We're like, these EDTA chelated molecules, they don't care what the plant wants at any time. They just go into the plant because that's what their job is. So a lot of the times you get that harsh burning, and it's because of lab-made phosphates being really harsh. It's from EDTA chelated micronutrients that you're in the week 7 of flower, 6 of flower, and those are still being shoved into the plant whether you want them to or not. So what I want to do, and what I searched out, is I wanted to use amino-humic-based trace elements. So it's iron sulfate, manganese sulfate, copper sulfate, all the sulfate-based molecules of the trace elements, but they're digested and chelated to amino acids and humic acids. So you get the ionic uptake like you do with like the EDTA chelated trace elements, but it's in a form that's wrapped in carbon, the carbon molecules, humic acids, amino acids. And the biggest thing I wanted to do with this is most nutrient lines are nitrate based. We wanted to be carbon based. Nitrates elongate the plant cell. Nitrates grow plant matter. And which is good when you're trying to vegetatively grow a plant, but when you're trying to have the plant synthesize other molecules like terpenes and flavonoids and cannabinoids, all of those are carbon-based. So the limiting factor for the plant to be able to produce those is going to be the amount of carbon you give a plant. So I wanted to make a nutrient line that was carbon-based, where everything's wrapped in a carbon ring. So one, it's microbial food source. When you're putting it into an organic system, it's a microbial food. Two, I wanted it to be bioavailable, so if you put it into a hydroponic system, it's still 100% bioavailable plant nutrients. So these two bases really encompass your amino acids, your seaweed extracts, and your humic acids, along with all of your macro, secondaries, and trace elements. So that's our base fertilizing system. Then you have the supplements. You have the calcium, which is an organic CalMag. Uses calcium carbonate, magnesium sulfate that's digested into amino acids. So it's a protein sulfate-based calcium product. So a lot of the times when you use CalMag inside these synthetic systems are all nitrate-based. So when you're using them heavy in flower, it causes a bunch of foxtailing, and your flowers get a lot of airiness to them. With this, you have proteins, and calcium all go to building strong structure in your flowers, strong structure in your plant cells. The fact that there's a 3% sulfate charge on there, sulfur is in every single terpene. So it's a limiting factor for your terpene production based on how much sulfur you have going into the plant. So it's a CalMag product that's kind of designed to be used heavily in flower when you need it the most, but won't cause the foxtailing and goes to really fortifying the plant. The last of the supplements is the PK Blossom. It's an organic bloom booster, essentially. I wanted to take micronized rock phosphate, potassium sulfate, and calcium carbonate and put them into a concentrated product so you don't have to use Mother of all blooms, Moab. You don't have to use Cool Bloom. You don't have to use all these synthetic bloom boosters to get the flowers to grow, to get the plant to really set in and enlarge and ripen throughout its flowering cycle. And last but certainly not least is our flush product. Probably one of my favorite products. It uses a weak organic acid called hydroxycarboxylic acid. A lot of these flushing agents like Cleanse out there, like Drip Clean, they're all forms of bleach. So when you put them into your system, yes, they might remove the salt buildup. It might remove all of these excess materials inside your substrate, but it literally sterilizes it, nukes your entire rhizosphere. So all of your mycorrhizae, all of the microbes you've been using throughout your entire growth cycle, you put Cleanse in there, any of these bleach flushing agents, and it completely nukes out any microbes, and you just end up wasting your money. So what I wanted to do is make a flushing agent that was one, carbon-based to kind of go with this whole carbon-based fertilizing system, but two, make it safe for microorganisms. And it's probably one of the most diverse products we have. It's a water conditioner, so if you have hard water, it breaks apart the carbonates and bicarbonates and makes it soft water. In the soil, it acts as a soil conditioner, adds porosity to the soil, so it prevents compaction. So it's great for those no-till guys that over time you get the compacted soils. And we're dealing with annual flowers. We're not dealing with perennials. We're not dealing with ornamentals. These plants don't like a hard, compact soil. They want the aeration. They want the porosity. So this flushing agent, this flush, allows porosity to happen within the soil itself. And the third part is that it also acts as a nutrient chelator. So if you add it to your reservoirs, whether you're using salts or whether you're using organics, it helps break everything down and chelate and attach itself to these molecules, so the plant recognizes it as, since it's a carbon-based acid. So when it attaches itself, the plant can tell it has carbon attached to it. So the plant goes, "Oh, I know what carbon is," and grabs it in. So it makes your nutrients more bioavailable when you use it with your feeds.
I think you pretty much answered my next question, which is this product line usable with all water types? So rainwater, tap water, RO. It sounds like it is. Yep. And it sounds like even if you're using tap water and it's got chlorine in it, it's got chloramine in it, that you can still use that.
Yep. And the cool thing about these base fertilizers, because they have humic acids in them, they buffer out chlorine and chloramine. So they can actually help buffer some of the tap water. So when you're putting these organic fertilizers into your tap water and putting those into your soil system, you can actually help reduce the impact of chlorine and chloramine just by using the base fertilizers.
That's interesting. That's so cool. Now, pH is a big topic, specifically when it talks about, synthetic nutrients. You want them to be in a proper pH range so the plant can uptake. Same thing with organics. They need to be in that certain range. Now, what is your overall thoughts on monitoring pH when growing organic? There's so many people out there that say completely ignore pH. Whatever water you have, put in there, the microbes are going to adjust it. Then there are other people that say, no, you still want to make sure you're putting the proper pH into the medium in order for the plant to be able to uptake the nutrients, for the microbes to be able to work properly. What's your thoughts on that?
So I still like to keep everything in the soil system between 6.5 and 7.5. And usually most of these agents that you're using or products you're using are going to keep it there. But I mean, compost teas go down to 5.5 sometimes, and I don't recommend pHing those. You know, the soil will figure everything out. The whole thing about an organic system is that you're relying on your soil, the microorganisms, the organic matter, the amendments. You're relying on those, the limestone, to buffer and to keep everything stable. So Nectar for the Gods, for example, everything in there is all fermented, and everything in there is extremely acidic. You know, you still need to keep it up and raise the pH, and they have a liquid limestone product that works great. But once it goes into the soil, you're still going to have the high amount of hydrogen ions. That's what creates something acidic. It's high amounts of hydrogen ions. And what creates it alkaline is high amount of hydroxide ions. So you can buffer it, and you can get a stable pH and get an equilibrium. But you're still going to put these high amounts of hydrogen ions that you just buffered up, you're still going to put them into your soil, and the soil is still going to react with them. So the biggest thing about all these organic systems, I wouldn't worry too much about pH. Definitely don't do anything crazy that's going to like pH of like 10 or 12 that's going to, you know, throw anything out of whack. Don't put anything at pH of 4 or lower in there. But if you can stay between the 5.5 to 7.5 range, the soil will buffer and figure itself out. You know, that's why you got to rely. You're creating an ecosystem, and you have to be able to rely on that and not be, you know, constantly at the wheel all the time of trying to make sure everything's perfect.
Well said. Let's flip it up. Let's talk about PGRs, so plant growth regulators. So some people hear about PGRs and they automatically think bad. Bad, never use PGRs.
Yeah.
Everything about PGRs is bad.
Yeah.
I have trouble saying this word, but Plactrobutrazol. I just struggle saying that word for some reason. That's the one PGR that is really bad, right? That's carcinogenic, related to cancer. Talk to us. There are good PGRs, natural PGRs within the plant. Talk to us a little bit about PGRs, the good and the bad.
So, sure, absolutely. So, Paclo, for example, is a bad PGR. And PGR, for those who don't know, plant growth regulators. It's hormones, whether it's hormones that control and direct a function within the plant. So bush load has Paclo in it, right? So you go to an ornamental nursery, and you see all these shrubs the same height. You see them all the same width. You see all these perfect shrubs. Shrubs by themselves do not want to do that. They do the same thing as most annual plants do. They'd have an apical dominant side, and you'll see one branch go way up, and the rest of the shrub will be like kind of lopsided. We spray Paclo on it, and what happens is it regulates the hormonal function of the plant. So it gets rid of the apical dominance. And the apical dominance is derived from auxins, the one of the 5 plant hormones naturally occurring within the plant. So Paclo goes in there, tells the plant to stop doing that and to grow more lateral than to grow vertical. In the old 90s hydroponic days, you'd spray your plants right before you go into bloom. All of them stay horizontal. You kick down the stretch by almost no, you have almost zero stretch. You kick it down almost all the way, and you have these nice little fat, you know, bushes across the way. The thing about this, and what I don't like about PGRs, is most PGRs are carcinogenic. So they're cancer causing, and you know, when you're using ornamental plants, people use these chemicals on them, and you're not eating an ornamental plant, you're not smoking an ornamental plant. You know, it's very much one of these things of like it's used for kind of like a hands off, you're going to look at the plant type of situation. When we go into consumable crops, then we have an issue with these PGRs becoming cancer causing because we're literally ingesting them, and these half-lives are sometimes 6 to 12 months at a time. So by the time you finish the cycle, it's still existing within the plant. You know, it's really important to know that PGRs are bad, But it's also important to understand, and this is where I kind of, AFCO is a overlying agency that we have to work within. They decide what your heavy metals are. It's a government agency that dictates what fertilizers, what ingredients we can use in our fertilizer products that we sell you. Most of these all these PGRs are under the pesticide branch, so they're very much restricted, and they have a very strict standard in which you have to use them. There's protocols to them. However, I argue with the government officials about this. I believe that there are plant growth promoters and plant growth regulators. You have, for example, you have the PACLO, the synthetic hormones. You also have kelp extracts, which has natural hormones in them. Alfalfa has natural plant hormones in them. And this, we have to get into like the monotony of what is regulating the growth of a plant and what is just promoting the growth of the plant. Because not all hormones that are categorized as PGRs are what I consider PGRs. So PACLO is a growth regulator. Plant growth promoters is what I call them, PGPs. And those are the natural hormones you get from plant extracts, algae extracts, seaweed extracts, alfalfa. Even amino acids have a plant growth promoting effect. Those are okay and those are safe to use. I recommend using those because those don't control and tell the plant to stop doing a natural function and do this abnormal thing like PACLO or bush load does, where it just levels out the canopy and gets rid of the apical dominance. They promote the stage at which the plant's in. So when I use a seaweed extract when the plant is vegetatively growing, it's going to help develop more nodes. It's going to help lateral branching. It's not going to tell the plant just to stop growing and just to rearrange its entire hormonal structure. Alfalfa as well, they're plant growth promoters. They're going to promote whatever stage the plant is in. And those what I want really the delineation between the PGRs and PGPs to occur. I want people to look for PGPs because those are actually what we can use to increase crop production without using any type of carcinogens to kind of harm our bodies, to harm the people we're providing medicine to.
Lots of good info there. Thanks for breaking that down for us. Let's move on to light cycle, particularly the 24-hour light cycle. So there's a lot of people that say 24-hour light cycle is the best light cycle for vegetative growth because you're going to have that photosynthesis going and going and going and going. People on the opposing side says that the plant needs the period of darkness. Now, there have been studies that, particularly on the period of darkness, to where things that happen down below, in the soil, microbes, exudates are being released during the darkness period. Can you give us your overall thoughts on the 24-hour light cycle? Is it bad?
I'm not a fan of it. I like to give plants a rest period. Because as soon as the lights turn off, you have a whole bunch of hormones being rerouted down to the root zone. Abscisic acid, so there's 5 plant hormones. There's cytokinins, there's auxins, there's gibberellins, there's abscisic acid and ethylene. Normally when you're seeing the top growth in the canopy, you're looking at cellular elongation, auxins. You're looking at cellular division, cytokinins. You're looking at cellular bulking, which is gibberellins. But what happens below the subsurface of the soil, the roots are releasing abscisic acid and ethylene back and forth to grow left, to grow right, to grow down, to grow up. So that darkness period I like to give the plants because the plant is allowed to hormonally rearrange itself naturally and actually use those hormones in the root zone to do its natural function that it would do in nature, naturally.
Gotcha. Okay. And now kind of piggybacking off of that, some people do an extended darkness period before flowering. Now this comes down to phytochrome, PR in the awake state, sleep state, PFR. When PFR accumulates more than PR, the plant starts making phlorogen. Phlorogen is the flowering hormone. So it's often said that giving your plant a period of darkness, an extended period, some people do 36 hours of darkness between vegetative and flowering, that's going to help them accumulate more PFR, make more phlorogen, transition to flower faster. Was that all correct, what I just said there? And is that true or not?
Yeah.
What are your thoughts?
So theoretically, yes. On paper and textbook, that is how the plant does its dark cycles and how it rearranges itself. The issue we get into goes across collegiate studies, this goes across third-party laboratories, it goes across the government. So it's so hard to quantify this biochemical reaction that's occurring and to know what levels are where, because the plant's constantly going through a metabolic change. And this is where the government doesn't like us to be able to list like algae extracts or seaweed extracts and say they have hormonal activity, because we spray it on there and then we don't know. We can't quantify, like, yeah, we know the plant grows better, but we are not able to quantify how much of these hormones are going into doing what and what the biochemical cascade is doing. You know, we as humans are still figuring out what these plants do and how to quantify them properly in an effective manner. So, I mean, I personally, and this is where the scientist in me comes from, I personally do not know how much fluorogen is being produced in those dark cycles. I can't tell you yes for sure that is happening. That's where I would call bro science. You know, where we know that this process happens, so we can extrapolate and be like, hey, what if we do this to our plants, and then that theoretical thing would happen to them? You know, and so that's like I like to be able to quantify things. So growth rates, root production, lateral branching, production weight, biomass weight, usable medicine weight. You know what I mean? I can quantifiably touch those things, and I know that's happening, but I can't quantifiably say that yes, I put my plant in darkness for 36 hours, and all of a sudden I cut a week off my flower cycle. You know, that's where bro science, it's like we extrapolate it and then we apply it and we think it does stuff and then we just keep doing it because that's what everybody else does, you know?
So bro science until it can be confirmed as actual science. If
Yeah,
it could ever be
exactly.
measured,
And
right?
same thing, yeah, totally. And same thing with the dark cycle at the end of the plant life. I know that, I'm sure we're going to get into that conversation too, where it's like you know, the theory is that the plant produces more resin whenever the sun's about to come up, because anticipating being hit by UV radiations, and the resin glands is spherical and perfectly spherical, where it diffracts the UV radiations before it hits the plant tissue. So if you leave a plant at the end of its life cycle in darkness, you can increase resin production. But again, bro science, because we don't have any quantifiable data. And in the research I've seen that people, you know, take it to a lab and they get their flowers analyzed afterwards, there's no consistent data that shows it does increase trichome production, increases cannabinoid levels, increases alkaloid levels. You know, we have been able to see that drought stress in like peppers increases capsaicin content. So you could extrapolate and cross apply that to the medicinal plants and be like, well, if it happens here, it'll happen there. But again, we don't. It's all bro science. We don't have any quantifiable data to show yes or no.
I'm glad you brought up the darkness before harvesting. Typically, people do 48 hours of darkness before harvesting, last-ditch effort to create trichomes, but then the opposing side says, well, even if you are creating trichomes, they're not going to that potent state, right? There's not enough time for them to be in that potent state. So I'm glad you kind of clarified that. As of right now, it's bro science until we actually have studies done on it, right? And can actually turn it into actual science potentially. Now, kind of going into trichome development, you know, when we talked at MJ BizCon, you talked a little bit about trichome development. You know in detail about how, when trichomes develop. Can you explain to us kind of just, I guess, the life cycle of the trichome, or just everything you know about kind of trichome development?
Trichomes by themselves are a defense mechanism that the many plants have to protect themselves from bugs. Creates a sticky surface, so when the pests are walking through, they get caught, and then they die from lack of water, lack of food, etc. They contain fragrance molecules that attracts and deters certain pests. Trichomes themselves also usually contain the alkaloids that everybody uses to partake in. It starts off as you have a stalk, a basin of it, and then you have a gland on top. Those are all silicon based, the stalk to the gland. And over time, the plant starts filling those glands with oils. and starts filling in with different alkaloids and whatnot, which is why you can see it go from clear to cloudy to amber, because you're literally watching a biochemical reaction happen throughout a period of 2 months. Plants naturally, and even in the vegetative state, same with tomatoes and same with medical plants, they have trichomes on them. They don't have any type of active material in them until later on into the stages when the plants can biochemically produce that, because it takes all the hormones and everything in the flower cycle to actually generate those active compounds in them. The plant starts off with CBG, and that's when you see the clear trichome heads. The CBG is a precursor to all the other cannabinoids, and then it goes into your active ones. CBD, CBG, CBC, all of those cannabinoids, and then it all terminates into CBN. So when you start to see the amber, that's when you start to see the CBN arrangement start to occur, the chemical reaction to turn all those actives into a more sedating compound. And then you start to see the glands start to wither and start to wither away, and that's usually when you know the pull during peak ripeness.
So how long does it take? I think you mentioned 2 months for that entire process to happen. Is that true? It takes 2 months for it to go from clear to cloudy to amber. Do we have like timeline for when it turns?
That's a general broad stroke. 8 to 9 weeks is our general flower cycle for most of our commercial cultivars. That's not how it necessarily works with 16-week sativas. 18-week sativas, those will stay CBG until 9 weeks, and then after 9 weeks, then they'll start to convert into the active cannabinoids, and then from there it takes another 2 weeks at the end of it, so it can be 16 weeks of a flower cycle to get all those cannabinoids to fully mature and fully evolve into their peak potential. So it really depends on, sometimes there's a 5-week. Sorry, not 5 weeks, 7-week photo period. Sometimes you get auto flowers, which are 5 to 7 weeks throughout the entire thing, So it really depends on the cultivar and the variety and where it's from throughout the world, because, you have equatorial sativas, you have things in the northern, southern parts of the world that are going to always mature differently. So it really depends on your variety, and that's why I recommend everybody know your variety to the point where you know what that biochemical cascade is doing at the time that's doing it, so you can pull at peak ripeness and not have to go too far and start to have cannabinoids degrade, or go too early and have it be premature where they didn't actually develop into what they should be developed into.
Gotcha. Now, do you have any tips for increasing trichome development? Some people, talk about UV, adding a UV, I think it's UVB, if I'm not mistaken, towards the end of the light cycle, just for like an hour or so per day. Some people say there are different nutrients that you can feed the plant towards the end of the light cycle that's going to help with the resin production, trichome production. Do you have any tips for increasing trichome development?
Well, yes. And that's kind of where I got into making my fertilizer line. Because it's carbon-based, everything about a trichome is carbon-based. I think the universities and all these, the conventional way to grow crops kind of missed the ball in one avenue of it, where they say that you need 17 essential elements to grow the plants, right? You have carbon, hydrogen, and oxygen, which are freely supplied that you don't have to provide yourself. And this is where I kind of stray away from the collegiate teachings of agrochemistry and agriculture, where you do need to provide carbon. You do need, and CO2 is a form of carbon that you can increase production with, It creates faster photosynthesis. It can increase yields. It can increase growth production. The thing is, though, you need to add carbon in a form that goes through the root system. And the plants take that, and that's what the plants use to make terpenes and flavonoids and cannabinoids. And in turn, that's the material inside these resin glands. You increase more material inside these resin glands, you provide more precursors for production of resin glands. Like resin glands are silicon based. You know, if you don't have very much silicon in your system, the plant isn't going to be able to assimilate that. It's not going to have materials to assimilate into a resin gland. You know, so I mean, yes, you can add. The lighting is indicative of how much trichomes are produced, and that's because trichomes are a natural protection from UV radiation. So if you increase radiation, your plants will naturally increase trichome production, which is the UVBs or the plasmas at the end of the light cycle. You see CMHs have a higher blue, and higher blues are tighter wavelengths, so the plant needs to produce more trichomes to protect itself. But first and foremost, what I would say is make sure your nutritional regimen is geared to producing those active compounds, because that's what we are all growing this for, to have the medicinal effects on our body. Again, nitrate-based systems are going to grow more plant matter. Carbon-based systems are going to grow more cannabinoids, more alkaloids within the plant. So really, it's making sure that you've got your nutritional regimen dialed in, and making sure your lighting is sufficient to the needs of the plant to produce the trichome coverage you're looking for.
Okay, let's transition over to flushing. One of the more highly debatable topics out there. There has actually been studies on flushing. And when we talk about flushing, there's so many definitions now, it's crazy. There's flushing as in running a large amount of water through the medium before harvest, so you're trying to reduce the ppm in the medium as much as possible, so that way that the plant will start to fade, the chlorophyll will break down in advance. Then there's leaching, which is basically just stopping feeding nutrients for the last 2 weeks, and some people call that flushing. But really the goal for flushing, I think a lot, is to see a fade or see a senescence in the plant in order to, I mean, so many people say different reasons for this. Some people say that it's going to reduce the amount of nutrients in the actual plant, and it's going to provide a cleaner ash of smoke. I mean, I've heard so many different things. Arc Screen Technologies had a study on this. I'm not sure if you saw that or not, but they came to the conclusion that the length of the flushing period did not impact yield, potency, terpenes, or taste characteristics, which taste characteristics can be subjective, right?
Right.
But the argument against that is that, number one, they're a nutrient company, so they're going to tell you to feed nutrients all the way up till the end because they make more money that way.
Right.
So some could say that that's biased. But the thing that they didn't measure, which is what I'm interested in, is the amount of chlorophyll, right? We know chlorophyll breaks down during drying, curing process, right? Mm-hmm. But flushing or not feeding nutrients for the last couple of weeks, having that fade happen, a lot of people say that the chlorophyll is going to break down during that period, and it's going to lead to a faster cure in a sense, right? You're not going to taste that chlorophyll weeks or over a month after you've dried and you're in that curing stage. Sure. Now, there haven't been any studies. You need a, what's it called, spectrometer to measure chlorophyll, so that hasn't been happened.
Right.
Long story short, what's your thought process on flushing? Do you think it's beneficial? Do you think it's not beneficial?
So, where to start with this? There's so many different angles. You're right. There's so many definitions for flushing. Right. So, okay. So I like to look at this in two different avenues, like harvesting flushing or oh crap, I messed up flushing, right? So you look at the oh crap situation. It's you fed too much, you're trying to do what everybody else is doing, hitting a 5 EC, peak flower, you're trying to crank out the weight in your commercial facility, yada, yada, yada. You get lockout. Everything starts tanking downhill. The plant's taking in too many nutrients versus water, and the plant's dehydrating now. And now you see nutrient burn across the board. You see deficiencies left and right. That flushing, I would use some type of agent to break the bonds of all the salts inside your medium and release them and flush them out and drain them from the medium themselves. That flushing is like a corrective flushing. I'm all about corrective flushes. Synthetic mediums are a little bit easier to corrective flush than like in organic systems because you have the organic matter that ties everything up. But that I do agree is a needed flush, and that's really what I consider the flushing mechanism. Now, when you go towards the harvesting side of things, I like to look at harvesting more like a ripening perspective than just a get rid of everything there and let the plant fade type of thing. Naturally, inside like organic systems, the plants just naturally, you're going to deplete the soil, essentially, the reservoir capacity. You're going to deplete it, and the plant's going to take up less and less nutrition, which causes cannibalism. So there's anabolism and cannibalism. Anabolism is the plant takes excess external materials and synthesizes them into proteins and synthesizes them into the plant nutrition. When the plant has a lack of nutrition coming in, a lack of elements coming in, the plant cannibalizes itself and starts to rearrange where the nutrients go to the most important members of the plant, either the flowers or the fruits. Because that's what you need to preserve in order to allow the genes to continue on, right? So what I like to do is gradually reduce the amount of feed towards the end of the life cycle and let the plant cannibalize itself, because I believe that's where all the flavors and that's where all the biological molecules that end up being all these smells and all these flavors and breaking down the chlorophyll will happen. And that's mostly what that's for is because when the plant ripens at the end of its life, when senescence is happening, the plant takes the boron, creates borosaccharate. And borosaccharate or borosacralose is a sugar that the plant takes from the leaves and translocates to the flowers and fruits. So you want that translocation to happen, and this is where like these nitrates, heavy nitrate diets, you really have a really hard time getting that fade without just stripping everything out of the medium and letting the plant have like literally just water for the last 2 weeks to cause that type of translocation senescence to happen. I like to do that naturally and let the plant naturally break itself down. And with these carbon-based ingredients, like I do with my products, it allows the plants not to be constantly fed nitrates to get their elemental uptake. They can get all their elements without having the excess nitrogen. And I believe these excess nitrates give too much nitrogen, so it causes an overabundance of chlorophyll to stay inside the flower, and that's why you get that hay smell, and that's why it's harder to get, you have to cure longer in synthetic systems to get a good flavor out of it, because you're constantly perpetuating chlorophyll to be produced by constantly feeding it nitrates all the way to week 7, week 8. So RX Solutions, was correct in their studies where it's like, yeah, it really doesn't, it doesn't affect cannabinoid production. It doesn't affect terpene production. But what I think it comes down to is exactly what you said. It's like, how fast are you allowing chlorophyll to break down? And I think that at the end of whether you flush at the end or whether you're allowing the plant naturally ripen through just a naturally depleted medium, I think that's where we're all trying to get to, is at the end of the plant's life, you want that chlorophyll to break down. So you don't want providing it with a bunch of nitrogen at the end of its life cycle, because that's what's going to hold on to that hay smell and not allow the proper essence of the flowers to come out post-harvest.
Well said.
It's a tricky topic because like flushing is just like this general broad statement,
Yep. Have you heard of ice flushing?
Yeah.
Yes. Can we talk about that?
Absolutely. Bro Science 101. I don't think the temperature of the rhizosphere has anything to do with the senescence or the ripening process of the plant. The plant isn't like sitting out in nature and just like, oh, cold water is being sprinkled on me right now. I totally know to start killing myself and to ripen really quick. I think cold water can lock out some things so you get better colors, because you have a different production. You have a different amount of elements going into the plant. The plant's not able to properly take up certain things, so then you have a different biochemical reaction happening. But I don't really think ice water flushing has been quantified to do anything other than make you feel good that you're kind of doing biomimicry and kind of emulating nature, which is, that's what you're trying to do. By all means, dress up as a tree and stand next to it. You know what I mean? Like, do whatever you feel like makes your harvest great and everything. But as a scientist, quantifiably speaking, I don't see ice water doing anything other than adjusting the temperature of the root zone, which shocks the plant.
You brought up bringing out the colors as well. Colder temps towards the end of flowering is another kind of old school trick in order to bring out the colors. What's happening with the plant when you kind of lower the temps and the colors come out?
Lack of chlorophyll production is what it is. Plants are green because chlorophyll, so by the weather changing and doing all these things is locking out the plant's ability to produce green. So then you start to see the true colors of the plant. And same with like when the plant starts to cannibalize itself and starts to break down its own chlorophyll and start to do that fade. You're seeing the actual true colors of the plant. Plant's only green because of chlorophyll, because that's the color it takes to absorb the sunlight, to absorb the photons. So I think with cold weather happening, it just changes how the plant's able to produce chlorophyll, and the plant naturally knows towards the end of its life cycle it doesn't need to produce chlorophyll. So when the weather happens, it triggers a biochemical process to allow the plant's anthocyanins or all these different colors to come out.
Interesting. Okay. How about stem splitting? You ever heard of stem splitting? Those in favor of the technique argue that it stresses the plant in a beneficial way, forcing it to uptake more nutrients and produce bigger, more potent buds. What's your thoughts on stem splitting?
Anytime people are trying to do one little trick to get bigger and more resin-coated buds, I always kind of like cock my head to it, because it's not a one way that's just going to make your buds be big. And stem splitting does stress, and it's the same thing with like low stress and high stress training. It can cause the plant to be a little more vigorous because it has to fight through the stress, and then once it heals the wounds, the plant already has that much energy going to it. I don't necessarily enjoy stressing my plant out more than I need to and creating open wounds. I feel like it takes away energy from other parts of the plant. Stem splitting, again, I haven't seen any data showing that it increases yields or it increases. I mean, I can see that it might increase cannabinoid production only because you stress the plant, and the plant produces metabolites when you stress it. So I maybe see that, but as far as like vigor and growth, I prefer, if I could have a plant where I didn't even have to top it and it could just grow laterally and just like be a huge bush, I'll just do that and feed the crap out of it, and just maintain a good harmonic system within the root zone to the plant. Make sure the pH is stable, make sure the ppm is right on point where I need it to be, and just hit it with as many growth promoters and microbes as I can. So like I said, I say stem splitting more of a bro science.
Gotcha.
Than I do any technical, and it's not really commercially viable. I mean, if you look at it, like if you have a couple plants, you can definitely do that and you can baby them. But if you have 100, 300, 500,000 plants, there's no way. You're going to cause way more problems than you're going to get gain out of it.
Gotcha. Okay. Bud washing. Let's talk about that one. So washing your buds after harvesting.
I love these questions.
I saved the best questions for you.
Yeah, I love it. Thank you.
So bud washing, just a quick explanation of what it is. Some people, they'll dip it in, they'll have a couple different buckets. So they'll harvest their plant, and then they'll dip it first in baking soda and lemon juice, and then they'll go into water, and then they'll have another one that's water. So they're washing off their buds, any debris that's on there. Supposedly there's a chemical reaction happening with the baking soda and lemon juice that's allowing some of the debris to be broken down. What are your thoughts on bud washing? What do you know about bud washing?
I have always been against it. I like the completely natural approach. Even outdoor flower. My favorite flower I've ever grown and smoked has been outdoor cali plants. And that's no washing, no anything. But I have seen there's a guy on Instagram named Heavy Icer. His name's Aaron. Really has to look out for his health, which I mean all of us do, but he especially. And he's been really, really good about hands-on tutorial with like bud washing and making his own solvent lists and whatnot. He really gave me a change of perspective where he had his 3 vats. He dipped, and then at the end of it, he had his outdoor plants, so he had nice couple pound plants. He did a bubble bag collection at the end of it through like a 15 or 25 micron, and because everybody says like you dip and it's going to take away all of your trichomes, and you're going to lose all of the material you grew doing that, and he had barely anything in that 25 micron screen. And he took all of it, probably took 90 gallons of water that he used to wash all of those plants with, and did a collection at the end of it. And there's only like gunk. There's only stuff in there that you probably don't want to consume. So after seeing that, I was like, I actually understand this methodology now because, like, yeah, it's dirty outside, and there's with all the smoke and all the ash, bugs, bird doo-doo, you know what I mean? Like, there's a bunch of excrements from all these natural insects, natural animals out there that you probably don't want to be consuming. So I actually now think of it as a legitimate answer to dirty flower. Mind you, it's not going to get rid of your PM. It's not going to get rid of your aphids. It's not going to get rid of your spider mites. I mean, you'll wash them off, but like you should handle that before you even get into flower, or when you get in the beginning of flower, to make sure the last 4 to 7 weeks you don't get anything on your plants. But if you're really concerned about your health and you do want clean flower, then yeah, absolutely wash it. Now, I don't know about residuals. I haven't done any residual analysis, and that's the one thing that I would be concerned about, because like lemon juice is citric acid, sodium bicarbonate is baking soda. So I don't know about the residuals. That would be my question, is what I would go to like next in my hierarchy of how I kind of discover these things, my discovery process. I'd see about the residuals after I go, okay, that's a good process to make sure my flower is clean. Now, what are the residuals on it? Because I still don't have any data on if there is any residual on it. I personally have never consumed materials that have been washed, so I mean, I can't really say for sure if it's like qualitatively good or bad. But you know, I guess what I'm trying to say is I can see it as a method to clean flowers if you know it's outdoor or you have dirty flower.
Gotcha.
Like the actual dirty, not like dirty as in like, oh, it has buttloads of PM on it. How do I remediate this now? You know?
Gotcha. That makes sense.
Mm-hmm. Mm-hmm.
All right, let's wrap things up. We went over a lot in this one.
We have.
Tell us, how can the listeners find you, and what do you have upcoming in the future?
So you can find us on Instagram. I'm very present on there. I run our Instagram page, so at cul.tur.ed. We're on Facebook, Cultured Biologix. We have our own group called Cultured Growers, where we do like exclusive releases and discount codes and whatnot. You can also find us, if you're trying to find our products, go to your local store. Say hi to them, go medicate with them, you know, go hang out like it's our old barbershops, how it used to be back in the day, and go ask for our products upon their shelves. We like to work directly with retailers. You know, we want to support the stores that are supporting you. So if you have a question or you have a problem that you don't know the answer to and Google's not helping you, go into the store. Those guys will probably help you. Most of those guys back there are really cool, and they're probably going to be your best friends. The other, you know, easy way to contact us directly is you can go to info@culturedbiologix.com. And that goes to all of the executives. And so any question you ask us, tracking or anything like that, just say hi. Feel free to just shoot us over an email. As far as what we have next, you know, we just launched the Fertilizer line. So we're trying to get into all the stores and get samples out. We're doing a bunch of samples campaign. We launched samples about a month ago, and we already have close to 300 sample kits being sent out. Not on top of the sample kits we're sending out to stores. So things are going gangbusters right now for the Fertilizers. So whether you're in hydroponics, soil, whether you're doing some type of medium between the two, check out Eon. It's you know, our organic fertilizer system that's able to be used in hydroponics all the way to soil. Essentially, I like to grow good medicine. I want everybody to grow good medicine. So what we're really trying to do is pump this really hard and get this in as many people's hands as possible, because I really do feel like this is the next evolution in our how we grow plants. So we're gonna be focusing on this pretty hard, because I'm dead set on doing things a little differently. So yeah, we're just cranking away. And then for all you New Yorkers up in the Northeast, we're going to be at NYC CannaCon, I think the first week of January, I think it is. So come check us out. Come say hi. You know, come share love.
Cool. Well, I will leave a link to Tim's Instagram down in the description section below. If you enjoyed this video, click that thumbs up button. Try to get as many thumbs up as possible. Share this video with people who you think would benefit from this information. Subscribe to the channel. You know, if you're on YouTube, subscribe. We're releasing these podcast episodes every single week. If you're listening on one of the podcast platforms, particularly Apple Podcasts, please leave a rating and review. Let us know what you think of the podcast. I read every single piece of review that is left. Thank you to all who have left a review. I think we're coming close to 200 ratings and reviews. So appreciate everyone who has taken the time to leave a rating and review. Tim, thank you so much for coming on to the podcast today. This was awesome. This was fun. There's a lot of myths in this industry, and you talking about what's actual grow science versus bro science, I think this is going to bring a lot of value to a lot of people. So once again, thank you for coming on to the podcast.
I appreciate it. Thank you for having me, man.
All right. Have a good one.
You too.